Hello, everybody. Hey, welcome to Chapter 9, Electrical Systems. I'm going to have two videos for us on this one here. It's kind of a long chapter, so I want to just kind of break it up in two. I'm going to kind of briefly go over the chapter, and that'll help us complete our study questions. We can fill those out as we go along on this first video, and then I'll dive into showing you how the voltmeter works, check fuses. We'll look at some belts. I'll do a starter, a bench check on a starter, show you alternator, regulator, etc. We'll go over some of those things and test light, voltmeter checking out, voltage in a battery, etc. So without further ado, let's get started on this chapter. And if you want to follow along with your study questions, you sure can. Here we are, Chapter 9, Electrical Systems. What is electricity? What is the purpose of an automotive battery? What is the difference between voltage, current, and resistance? The automotive electrical system consists of wires, motors, fuses, relays, switches. This chapter provides the basics on how to maintain, test, and repair electrical system components. Okay, so electrons move from one atom to another, causing electricity. So electricity flows through a conductor, a wire, if you will. A lot of times copper, that's a good conductor of electricity. So voltage is the electrical pressure, okay? That's the electrical, that's what causes current to flow. That's electrical pressure. Current is the quantity of electrons that are flowing, and we measure those in amps. So amperage is what we measure with current. Resistance, the resistance or load in a circuit. Could be a bulb, could just be a regular resistor, something in the circuit that creates resistance to flow. Okay. Electrical symbols, you'll see these in maybe different ways here. The math symbol for volts is E, and the unit symbol is a V for voltage there. Amps is I for intensity. We measure with amps, current with amps, and so they use an A there. And the unit of measure for resistance is ohms. So we measure resistance in ohms. And there is a little symbol for ohms. And watts is electrical power. We don't really deal with that a whole heck of a lot in the automotive electrical systems. Okay, wiring diagrams. You want to familiarize yourself with some of these symbols if you're going to be checking out wiring diagrams. Online, you can go online and get references to what these symbols mean, like this is a ground, that's negative, that's positive. There's a resistor. That would be an open switch, for example, and that is for a battery. Electricity explained. This is Ohm's law. Maybe some of you have heard that. It takes 1 volt to push 1 amp, so that's the current going through there. It takes 1 volt to push 1 amp through 1 ohm of resistance, so it's a 1-to-1-to-1 ratio there. Ohm's law shows a direct relationship between the volts, amps, and ohms, and if you know 2 of the properties, you'll be able to get the third one. Okay, that's just Ohm's law right there. So, for example, what is the current? Who wants to know what the current is? Well, if we know the voltage and we know that this resistance is 2 ohms, we take the 12 volts and we divide it by 2 ohms, and that gives us our 6 amps. We're not going to be digging into this too deeply. It's just a brief overview of what Ohm's law is here for you. Okay. Electrical circuit parts. A power source provides the voltage for the electrical circuit. A conductor provides a path for electricity to flow, and a load is the resistance in the circuit. A simple circuit has a power source, like a battery, for a pathway for electricity to flow, and a load. Here's a simple battery, a simple circuit. Get the bulb to light up, okay, and it just goes around in a circuit like that. A series circuit, 2 or more electrical loads are wired into a single path. So maybe you have a bulb and a bulb here or whatever it might be, and you have a switch, you have a fuse, and you have your power source. So if anything in here is disrupted, neither one of these 2 items here are going to work. It needs to complete the circuit. So it's just one loop right there. Okay. In a parallel circuit, two or more electrical loads are wired into separate paths. So let's say these are taillights back here. You got a right rear taillight and a left rear taillight. If one of these circuits gets a short in it or an open or the bulb goes out, the other side still has electricity flow through there, and that other corner will still light up. That's a parallel circuit, for example. There's also series parallel circuits, a combination of the two. When an electrical circuit does not make a complete loop due to a break, it's called an open circuit. So an open circuit would not allow anything to work once it's past the break, right? Maybe the fuse is broken or break in the wire, that's an open circuit. And if you put a test light back here or a voltmeter, you would have 0 volts. That's a break in the wire, open circuit. Get a lot of that in cars. Here's a unwanted path. You've got two conductors of power, and it is called a short to power or short to voltage. So you got actually a voltage wire being shorted to another voltage wire. That's not very good either. When an unwanted path is created within a circuit, this is called a short to ground. So if you have a power wire and the outer portion of the wire, the insulation gets rubbed off and it rubs against something metal, that would be a short to ground, and that would definitely blow a fuse. So that's a common occurrence as well. Another problem a circuit might have is excessive high resistance. This is commonly caused by a corroded or loose connection. Could be a corrosion in a light bulb socket. There could be a lot of corrosion there that causes high resistance, and the bulb will actually be dim or much dimmer than it should normally be. Digital multimeter can measure volts, resistance, ohms, and current. Always follow the directions. I'll show you how to use this voltmeter here in just a little bit. There it is right here, just kind of a little pictorial. They're putting the positive on the positive post and the negative lead on the negative post, and it's reading 12.6 DC volts right there. And this is measuring resistance. I'll show you how that looks in a voltmeter here in your second video. We put it on resistance, and it's measuring the resistance in the particular circuit with the circuit not powered up. We don't want to run electricity through a circuit when we're trying to measure the resistance in that circuit. And this is what we measure current with. The wire would go through this hole right here. So you'd open up that clamp and clamp it around the wire, and whatever current is going through there is measured on your meter. Okay. Fuse box contains circuit protection and control devices like fuses. It's also called a fuse block, fuse panel, power distribution box, or electrical center. You may have a couple of spots for this one out underneath the hood. You may have one or two of these out underneath the hood, and you may have one or two actually even underneath inside the vehicle on the kick panel or underneath the dash. Fuses, there's a bunch of different kinds of fuses. I'm going to show you a little bit about these later as well in the second video. There's a glass cylinder fuse, a cartridge type, a blade type. There's all different sizes here, and they can make these in different ratings. A common rating is 5, 10, and 15. That's how much current will go through the fuse before it actually blows the link in the fuse. They're showing a good fuse right here. We call it a sacrificial strip, yeah. So if it gets too much current through there, it heats up and it actually blows that little circuit right there, or that little strip right there in the fuse, okay? Fusible link is a short piece of wire that has a smaller diameter that rests in the circuit. These were quite popular going between the ignition switch and the starter. And if these blow, you turn your key and you may have no current to the starter. But they can be in other circuits of the automobile. Circuit breakers are used to protect overload circuits. Circuit breakers reset after they have been cooled. There's one right there. There's your fuses in the fuse box right there. You've got a 10 amp fuse and that fuse blows, folks. Don't go reaching for a 15 or a 20 amp fuse to put in the 10 amp fuse spot. Whatever that fuse was protecting down the line may end up getting shorted out and destroyed, like maybe a very expensive radio, for example. Or maybe there's a fan motor that's shorted out and you're allowing current to go to it. You could end up with an electrical fire underneath the dash. So Just replace a 10 amp fuse with a 10 amp fuse and a 15 amp fuse with a 15 amp fuse, okay? Switches, flashers, relays. Relays allow a small current to turn on and off a current requiring a higher load. Okay, batteries. Two types of batteries, flooded batteries. In a flooded battery, the plates are covered with a liquid electrolyte, sulfuric acid and water. I'll show you that in the second video. A dry battery, AGM battery, a thin layer of ultrafine fiberglass mat separator absorbs by electrolyte. Those are newer style batteries. Battery terminals. Some battery terminals have a top and side mount systems. You buy a new battery now and you've got an option of putting regular cables on there or the side terminal cables on there. A fully charged battery, of course, is going to have about 12.6 volts, all right? And they are rated in cold cranking amps and cranking amps. So when you go to buy a battery, you could buy the same physical size battery and actually have a higher rated battery or lower rated battery than the original battery in the car. And of course, the cost factor is going to go up for a higher rated battery. In other words, this battery could put out 875 cranking amps of power at 32 degrees and only 700 cranking amps at 0 degrees. Of course, when it's really, really cold, batteries have a tougher time of generating current to start the car over. So this is generally how they're rated. It depends, if you're going to hold on to your car for 6, 7, or 8, 9 years, or whatever, you might want to spend a few extra dollars and get the higher rated cranking amp battery if you can. Okay. This BCI is the Battery Council International. They work with the sizes of the battery. There are lots of battery sizes out there, folks. Size 24, 24F, 27, 27F, 64, 65, 78. There's just lots of different sizes out there. You need to know the specific vehicle, make, model, and engine size when you go to get a battery at the parts store so you get the correct size battery for your vehicle. Very important. Okay. Battery life and warranty. Batteries commonly last about 4 to 5 years. Warranty commonly includes a free replacement, and then it's prorated after that. So if you had a 4-year battery, it cost you $100 and it lasted 2 years and it went out on you, you'd get 50% credit towards a new battery. That's how that works there. They're giving you a explanation here on a 5-year battery. And if you used it 4 years, you'd get 25% credit towards a new battery. Okay, that's called prorated. That's what they call it. Make sure your terminals are free from corrosion. Maintenance-free batteries are permanently sealed. Some batteries have a hydrometer on the top where you can see the status of the battery. Battery terminal, make sure you don't get your hands or elbows or arms laying on a battery. If there's a little bit of dampness on the battery, it probably has sulfuric acid there, and that will really burn your skin. It's very, very painful. So wear safety glasses around batteries, wear gloves, be very careful. Baking soda, water, and an old toothbrush can clean up old terminals. Just don't reuse the toothbrush. Probably not going to be too good for your teeth. Well, they might end up pretty clean, but I think it's going to be very painful. So don't do that. Charging. When using a battery charger, be sure to read the manufacturer's instructions. Generally, we try and put batteries on a very low charge, 1, 2, 3, 4 amps maybe at the most, and charge them in a slow rate, for a couple hours. We don't want to be putting a battery charger on a battery, 30 amps for a half hour. That could actually ruin the battery. It'll definitely start to smell and stink and warp the plates inside the battery. So my recommendation is to charge a battery at a very low rate. But you can check with your battery manufacturer on that. Yeah, when you do buy a new battery, you usually turn in your old battery. They usually have a core charge on that, so you want to make sure you take your old battery in with you. We don't generally check batteries with hydrometers anymore. This is the specific gravity of a battery that's fully charged up. It would basically, the weight of the fluid in the battery would be 1.65. They call that specific gravity. And the voltage would be 12.6 volts. That would be a fully charged battery, 12.6. Okay. Let's see here. Nickel metal hydride batteries are used in hybrid vehicles and electric vehicles. Orange cables signify high voltage. These orange cables on hybrid systems, don't be hooking your radio into one of those. That's definitely going to be a problem. You need to wear special gloves to work around these particular orange cables. They're very high voltage. Don't mess with them unless you know what you're doing. Okay, wouldn't be good. Here's a starting system basic circuit. Here's an ignition switch. You need to have the car in park or neutral before this thing will obviously start up. There's a fuse. It's in park. The ignition switch will be able to turn on and energize the relay. The switch will close. You'll get voltage on one side of the solenoid, and you already have 12 volts going to the other portion of the solenoid sitting on top of the starter. Now I'm going to show you how that engages in the next video. We'll bench check a starter. Okay, I'll show you how that works in the next video. This is just a basic starting circuit wiring diagram. You could test this post right here with a test light. Just make sure you're getting voltage there, and you can test this post right here when you turn on the key to make sure you have voltage there as well. If you do, probably got a bad starter. Starting system, battery, ignition switch, and starter relay. That's part of the starting system. Solenoid sits on top of the starter here. The starter converts electrical energy into mechanical energy, okay, and cranks over the engine. That's what it does. Park neutral safety switch makes sure the vehicle is in park or neutral before starting. You've got to have either the clutch all the way in, or you've got to have the vehicle in park or neutral. Computer control starting requires certain conditions to be present before the starter will engage. Obviously, vehicle in park, etc. Okay. This is a charging system here. This is called an alternator, and this is what recharges the battery once the vehicle is started. It keeps the battery, 13.5, 14.5 volts while it's running. If this alternator goes out, of course, your battery is going to go dead. This is just a basic charging system circuit right here. Okay. And they have a serpentine belt. There's a belt that runs the pulley, turns the alternator, and that creates the electricity to keep your battery charged up. There it goes, keeps the battery charged. Yeah, I just said that. What do you know? It converts mechanical energy. Basically, the belt's going around it, so that's a mechanical piece. And it converts it into electrical energy going back to the battery. The battery itself converts electrical energy into chemical energy, storing for future use. Again, some batteries have monitors or analyzers, sensors built into them to measure the voltage of the battery. There's a voltage regulator that regulates the amount of voltage going to the battery. We just don't want the alternator just to go full bore and recharge the battery all willy-nilly, just running 40, 50 amps back into the battery. They have a regulator that measures how the battery is doing and tells the alternator, hey, give me a little more juice or a little less juice to fill up the battery. That is a regulator. They used to be separate. They were about that size, like a deck of cards. That's about what it looked like. And then they had the regulators inside the alternator, and now they actually can put them inside the computers, so the computer can regulate the voltage back to the battery. The computer, the power control module, the main computer gets inputs from sensors, decides what to do with it, and sends outputs to the controls like fuel injectors, that sort of thing. The inputs would be like coolant temperature sensor, intake air temperature sensor, etc. If anything starts to go wrong in the computer system for emissions, your service engine light will come on. An engine drive belt routing diagram is commonly located on an engine's compartment label or in the owner's manual. This is the routing of the belt, the serpentine belt or fan belts that you have on there. If you don't have that diagram on underneath the hood, draw it out on a piece of paper when you take the old belt off so you know how the new belt goes on. It can get quite confusing. If you draw it all out there, it'll be really easy to do. No problem. If that belt breaks on this particular vehicle, you're going to have no air conditioning, no alternator, no water pump. You're not going to have much going on there. So the battery will go dead. Steering could be bad. Doesn't show a power steering pump in here, but if it ran a power steering pump, you would have no power steering either. So if the serpentine belt breaks, it's best just to pull over and get it towed. Serpentine belt, also called a multi-rib belt, is usually flat on one side, has grooves that run on parallel with the belt on the other side, and can have 2 to 8 grooves across here, and can be at least 1 inch wide sometimes. Okay. New belts wear similar to a tire. All they do is kind of lose rubber, but not necessarily do they crack anymore. So that's pretty good. And we have automatic belt tensioners. I'll show you what those look like in the next video as well. They have stretch belts now that are not the same as conventional belts. A stretch belt cannot be removed and then reused. Once it's stretched to be removed from the vehicle, you can't reuse it. So special techniques are used to install this particular belt. The removal process for these is simply cutting them. You just cut the belt. V-belts we used back in the day are less than a ½ inch thick and kind of taper into a little bit of a V. If you had one of these, you might have had 2, 3, 4, maybe even 5 of these on your vehicle back in the day. These start to crack in here, of course, simply replace those. A worn belt can slip, hydroplane, elongate, or become misaligned. You want to make sure that these belts stay lined up in the vehicle. If the pulleys start to get off a little bit, you can get belt squeal. The belt can wear out on one side and break prematurely. Generally, they're caused by the belt tensioner itself actually starts to wear out, and that's generally the problem. There's a belt wear gauge. I think I have one of those here. I'll show you those in my next video for showing you how to measure the belt wear. And factory numbers on old belts may be able to assist you in cross-referencing to a new belt. There's the part number on that belt. Generally, they're not going to be on there anymore. So just as long as you know the VIN number, engine size, year, make, and model of your vehicle, you'll be good to go. We have different bulbs now in vehicles. We got halogen, HID, and LED. The most important thing on these is to keep your fingers off the bulb. The new bulbs, when you go to install them, you don't want the oil from your fingers to be around the bulb. They can cause premature failure on the bulbs. So there's just showing you a couple different styles of bulbs here. Sealed beam headlights are common in older vehicles. These ones right here. Composite headlights are integrated aerodynamically into vehicles nowadays, and you'll have to get these bulbs out by going underneath the hood or through the trunk. Some light assemblies are non-serviceable. This means the bulbs cannot be replaced. These might be LED bulbs for brake lights, for example, the third eye brake light in the back. Generally, if a couple of these bulbs go out here, you've got to replace the entire assembly. So there you go. The starting system converts electrical energy, chemical energy into electrical energy to mechanical energy to start the engine. Charging system is what converts mechanical energy to electrical energy, keeps the battery charged up. Fuses are basically overcurrent protection devices. In other words, fuses protect circuits down the line from burning up, if you will. It's best just to change a 50-cent fuse versus a $500 stereo. So, and electric vehicles have an additional high voltage electrical system that runs electrical motors for propulsion. So there you go. So I know I ran through that kind of quickly there, but that should have been able to get you enough information to get your study questions filled out and kind of get you a head start on what I'm going to talk about in the next video. Go down in the shop and show you all these components and show you kind of how we check them and a little bit better description of the devices in the electrical system. So thanks for hanging in there with me. I know this was kind of a long video. I appreciate you hanging in there, and we'll see you here in the next video. Thanks. Bye.